Thank you. So before we begin, so this session will be about, so I'll tell you something about what's new brought us Kubernetes 1.8, and I'll show you some demo about one of the most awaited features in 1.8. And so first question before we really start, my question will be like, who already uses Kubernetes and like, does everyone know what it is about, like in general? Like, do I need to tell about something more about it, or I can just proceed with the session itself? Okay, everybody. Okay, and one more thing about Kublr. So Kublr is our solution for managed Kubernetes. So we are basically making software which allows you to roll out highly available multi-master secure Kubernetes clusters that you can use in production. But this is a side note, let's say. So what is Kubernetes 1.8? So this is some small dates and numbers. So it was released end of September, and it was third major release from this, starting from this year. So the current minor version is 1.8.3. So basically, they're trying to fix a lot of issues starting from 1.8.0, and so the next minor version, 1.4, probably it will be released like the day before Thanksgiving, like the initial note, but I don't know if it'll finish in time or not. And so it was very successful release. So they did a lot of commits, so thousands of contributors, and made a lot of commits and even more. Yeah.
Who was the release manager for 1.8?
I believe there was some guy from Microsoft, if I remember.
Yep. That's right. I remember there was something special about that.
Yeah. So 1.9 will be released like in less than 1 month, but I believe like by the time 1.9 will be released, 1.8 will be properly stabilized to be used in production. So the major features. So speaking from the user perspective, it was security improvements, workload improvements, and a bunch of new features which are currently alpha. And from non-end user perspective, it was changes in release. So they did changes in process, architecture formalization, and governance model in Kubernetes. So they're like trying to stabilize it and make it more, but it doesn't affect end users basically. So we are not talking about this now. So speaking of security improvements, so what we have. So first of all, role-based access control is now considered stable and should be used by everyone. Even more, if you create a new cluster by default, it will have role-based access control enabled. So you'll see a lot of new features running around. So what role-based access control does, it allows cluster administrator to enforce access policy through the Kubernetes API. And there is improvements on network policies. So there is ability to filter outbound traffic through network policy. So in previous version, they added support for filtering inbound traffic. So basically, in network policy, you were able to set up ingress. Now you also can set up egress. And node authorization improvements. So for example, there is an improvement in a bootstrap tokens and everything like that. And then TLS certificate rotation for kubelet now is considered beta. And automatic certificate rotation is the secure cluster operation. So then role-based access control, what it basically is so it's configured using standard Kubernetes resources. So users of your cluster can be bound to a set of roles, And there are two roles, so it's cluster role and role. The difference between those is cluster role is a set of permissions that are bound to the cluster itself, so it works across namespaces. And regular role is bound to the specific Kubernetes namespace. And those two objects, supportive objects, cluster role binding, control binding, basically binds your user either to cluster role or role, depending on what role you want to use. By default, all new Kubernetes clusters install a default set of cluster roles, and which are representing common buckets of users that can be placed in. So, for example, there is edit role, which allows user to perform basic actions like deploy in a pod or do deployment. There's also a view role, which gives you access, like read-only access to the cluster. And then there is a role cluster admin that basically give you cluster admin role, so you can do wherever you want on your cluster, the same way that you were able to do in previous version of Kubernetes. Okay, so how it looks like. So I'll show you an example of a role. The example for cluster role is pretty much the same, and it looks like the following. So it's a standard Kubernetes resource. It has an API group of RBAC authorization Kubernetes.ir/v1 kind role. You can see that it's bound to a namespace, alias, name of the role, and you define a set of rules which configures what your user can do or cannot do. Basically can do, because by default user can do anything because he doesn't have any roles attached to him. And here we have a configuration that says, okay, whatever user has bound this role, he has get, watch, and list access to my pods, my namespaces. He can view events for pods, and he can view services. So API groups, empty string. Empty string means like the core API group in Kubernetes. And I also want to give user to deployment replica sets and daemon sets. So those are API group for extensions, and I reiterate list of verbs that I want to do. So as soon as I created this role, I can create a role binding, and it looks like the following. Okay, I have a subject for my role binding, so this is like kind user, and it's my name. And I see, okay, the role reference is this one, and I can have several role bindings for the same subject, and I can provide set of subjects in a role binding, so it's quite flexible configuration that I can do. So security improvements, as you can see, okay, I'm trying to access my API, and okay, user anonymous cannot get, so forbidden. Go ahead and try to figure out how to connect to me in a secure manner. Just to show you a screenshot, like an example. Next one, network policies. Again, they were introduced in 1.7 in the previous version. Now they're improved, and the improvement basically shows us, so this is how network policy looks like that. Okay, so network policy allow you to configure how your deployments can communicate with each other. And here we say that those, so I have deployments that matches this pod selector. So basically to up Nginx. So I configured it ingress for application from a pod that labeled as app-foo. So if I have a pod that is labeled with app-foo, then it can connect to Nginx. If I don't have this label, or the value of a label doesn't match, then it won't work. And in 1.8, there is a new section called egress, and it will allow you to configure, okay, my Nginx can go to the foo or cannot go to the foo by default. And if you have, you can deploy like a default network policy which shows, okay, I want very secure deployment. I don't want anyone communicate with each other in my cluster. So I'm just deploy network policy which doesn't have in spec like empty pod selector, and your workload in a cluster can't communicate with each other, and then you can do case by case establish communication channels. So security guys will be very happy about it, that they can do it now. Addition changes that we were talking about. Okay, so first of all, as I just said, egress network policies allows you to configure egress rules in your network policy. Then now you can configure cross namespace policy. So you can, so the previous network policy worked only within one namespace. Now you can configure network policy across namespace. So basically what it means that you can do, if you have like 3-layer application, you have a front end, you have a back end, you have a database, you can put them in different namespaces and configure rules that will allow you front end talk to the back end, but don't allow front end talk directly to the database. So if someone breaks into your front end, it will not be able to connect to your database. So then you can also restrict traffic to specific port numbers. Again, pretty good addition and very useful one. And as you can see, we can now set up multiple ingress rules on a single policy. So you will have less number of network policies covering your whole workload. And for example, if we, like as an example, let's say I have an application which listens to the user input, and it also have a separate port for monitoring. Previously, I had to create 2 network policies for each port. Now I can merge them, like several ingress rules, to a single policy. Okay, workload improvements. So this is what a lot of people waited, actually. In the previous version, apps. So we had we had pods, then we had replication controls that are currently deprecated, and now we have like replica sets and deployment. And for the other types of the deployment, we had a stateful set and a daemon set. So deployment is just a regular deployment in a Kubernetes, and it just so you have define your template, and the Kubernetes will deploy. Create a pods according to your deployment. Basically, deployment will create a replica set, and replica set controller will create all your pods. So daemon set is required when you need like application that you want to run on each host, and stateful set allows you to create a stateful applications like deploy database and everything like that. There were a lot of differences between those. Now they're trying to unify them and make them to work more consistent across each other, comparing to each other. And for example, and one of the changes, for example, that they did for stateful set, when you do an upgrade for stateful set, the previous policy for upgrade was on delete. So you had to delete your existing pods for the stateful set, and then new pods will be created. Now they're switching it to rolling update. So you update your stateful set, and it will be updated automatically. So this is very good addition. And currently they are planning to promote deployment to V1 in next release. And there will be at least one change that I know for the daemon set. They added conditions, for example, in a spec. Addition changes. So now we have a cron jobs, so we can do periodic jobs on a cluster. So it's batch V1 beta 1, and it's again covers a lot of use cases when you have periodical jobs. Previously, you had to define, like, create a bike. It's not a bike. Create your own, additional scripts or whatever it is to deploy periodically the jobs. And another one is custom resource definition. So custom resource definition is so what it is basically. It allows third-party applications like one of the most probably known currently is Chorus operators. To create your own, so you can create your own resources in Kubernetes, and you can write controller which will be deployed, which will work on those resources. So you can create, okay, I have my, for example, one of the example, your cluster works in AWS, and you want to work with a database like which is Amazon RDS. So you can create a custom resource for RDS with a controller, and you just deploy your like Kubernetes spec. Okay, I want RDS, and it will be created, and it will follow the life cycle of a resource. Previously it was called third-party resources. Now they changed it to custom resource definition and do a lot of rewrites around to simplify API developers to work with those. So end users will be happy as soon as their cluster providers will introduce new features around it. Okay. Specifically, what changed between V1 Beta 1 and V1 Beta 2. So previously, if you don't define any selector on your deployment, then default selectors were generated for you. So you left them unspecified, and then defaulted label selector was generated for spec template metadata labels, and then you update, you prepare a new version of your deployment, you update your spec, then your default selector will not match. You do upgrade, and then your pods from a previous version stuck in your cluster, and you're trying to figure out, okay, what's going on. Now they deprecate them, and they also introduce immutable selectors. So these two features, what they basically mean. So you have to define your label selector for your pods so that all the upgrades will work as you intended. And Kubernetes guy says, okay, we always cautioned users against selector mutations, and now they say, okay, the selector itself will be immutable. So if you want to do so, like delete all deployment, create a new one if you change your selectors. Again, as I told, default will be a rolling update, so there is no on delete, like for example, for stateful sets. So update strategy for all kinds will be set to rolling update. And another one created by annotation is deprecated. So previously it was an annotation on your deployments and pods, wherever it is, which showed like who created this one. And now they say, okay, we are removing this, and we introduce you a new field like owner reference, and you can show reference like who created that. It's more useful for auditing actually. So you can update and it will be audited. And auditing is another feature that were updated in this release. Now let's go to smaller features, and I'll show like those covers different part of a cluster. So first of all, like for storage one. So for storage, now we have promoted to stable mount points. So mount options, sorry. So the mount options is the ability to specify mount options for volumes. And now we have in persistent volume spec, we have a mount options field, and we can specify mount options for a volume. So previously we used annotations for that. Now we have, okay, very good. And even more, we can configure mount options for dynamically provisioned volumes too. Next two improvements is around storage usage metrics and volume plugins metrics. So storage usage metrics, so the available capacity of a given persistent volume now available by calling Kubernetes metrics API. So if you intend to do some monitoring around it, so you can, now it's possible to do more easily. So volume plugin metrics. So we now we have metrics for success and latency metrics, and we can request like volume operations, including mount, unmount, attach, detach, provision, delete, like everything now. So we can collect those metrics and do some monitoring around it. There is a new alpha feature for volume resizing. So previously it was not possible to resize a persistent volume. Now it's done for Gluster FS plugin. So you can do volume resizing. And that's why it's alpha. It's supported only by Gluster FS. So in next versions, I believe that the support for AWS EBS will also be implemented. So Amazon AWS now supports volume resizing, so it's a very nice feature to have. So we can start with a smaller volume and then resize it as needed, and everything will continue to work. And the very early alpha is called volume snapshots. It's very early. It's even out of tree of Kubernetes. And what it does, it implements volume snapshots as a Kubernetes resource. So you can do, in general, like in a very future, it will be possible to take a snapshot of Kubernetes resource using Kubernetes API call and not ready for production. So because it's hard to ensure that snapshots are consistent and everything like that. So a lot of work behind it will be done in next releases. Next section is about cluster federation. So as you know, we can deploy Kubernetes in a federated mode when we have several Kubernetes cluster working under one federated control plane. And there are two new additions, basically. It's federated jobs. So federated jobs allows us to deploy a job to a federated cluster, and it will be executed in different clusters. And another addition, also alpha, so horizontal pod autoscaling now supports federation. So if capacity in one of the clusters ends, it will be automatically created in another cluster. This feature is really cool because it allows you to have multiple sites and you can autoscale between several clusters. So previously you had to do like crazy stuff like hybrid Kubernetes, for example. You have part of your nodes, so you have set of masters run on one site, but it will also had to manage another site. So you had one master that covers like 2 different deployments, and then trying to make sure that everything works. So now you can do normal federated cluster and pod autoscaling works, and you can do cluster autoscale on top of it. So and again, so it works the same way, as regular horizontal pod autoscaling, but in this case, what you actually do, like if one of your sites are out of capacity, like on you, it will be going capacity on you site on your cluster will be going up, and then if your resource usage goes down, then another cluster will go down. Next section is about node components. So node components is basically what runs on a node itself, and there is a lot of features around it, and I'll talk briefly about again autoscaling. So for autoscaling, so again horizontal pod autoscaler now supports custom metrics. So we can collect now custom metrics, and pass them to horizontal pod autoscaling to do calculation of our metrics. Cluster autoscaler itself. So the cluster autoscaler is a separate component which can be deployed on Kubernetes, which will do dynamic autoscaling of your cluster. For example, if you run in AWS, if you ran out of capacity on your cluster, cluster autoscaler will automatically spin up a new node in a cluster and connect it to a cluster, so you'll have increased capacity. So cluster autoscale is now considered GA, so it's stable, you can use it, but I know a lot of people used it already when it was version 1.2 or even less. And Now cluster have support to up to 1,000 nodes, at least so API server, one API server can serve up to 1,000 nodes. And cluster autoscale itself now respects to graceful termination. So earlier it was able to shut down your node before graceful termination. So now everything works correctly. And another set of features like CRI and so CRI stands for Container Runtime Interface. So what it is about. So previously Kubernetes was tightly coupled with a Docker, and the people at Kubernetes had a lot of issues with the Docker. So sometimes Docker does breaking changes and they don't test these things. And so there's always some issues around it. And Container Runtime Interface defines, okay, now we want to have like interface that everyone should conform to, and we can use whatever implementation we have. And one of those implementation is CRI-O, so it's like a reference implementation for Container Runtime Interface. And now it's considered stable, so you can use it, so you can now create a Kubernetes cluster which doesn't use Docker at all. Another thing is that Fracti. It is another CRI implementation for hypervisor-based runtimes. It's also considered stable, so again, you can use it without Docker. And CRI Container D, considered alpha now in the near future, so everyone will forget about Docker. So next set of features covers authentication. So first of all, advanced auditing is now beta. And what it means for us? It means for us that now we have introduced formatted audit logs and policies to control what should be audited. And there is a webhook to send events to external service. And audit events can now be configured to include entire request payload. So if your policy require you to collect a lot of information, like incoming information, you can collect all your payloads and aggregate them in a central location. And saying that this feature is beta is basically saying that now all the changes to audit log format will be done in a backward compatible mode, so you can plan to work with this feature and make your own, implement your own code that will use it, and be sure that there will be no breaking changes in the near future. One of the example, there is a tool called Audit to RBAC, and it consumes audit events and creates role-based access control profiles based on audit events. Set of features related to cluster lifecycle. So first of all, in previous version, Kubernetes had bootstrap tokens mechanism. Now this mechanism improved a lot, and it allows you to easily to add new nodes to the cluster in a secure manner. And another change is that conformance end-to-end tests for 1.8 passes on IRM 64 and PPC64 LU platforms. And what it basically means is that we can, in the near future, you will be able to run a Kubernetes cluster on your phone. If it's IRM 64 based, or you can use, you can set up your cluster on Raspberry Pi and be happy about it. Scheduling. So for scheduling, now we have 3 alpha features, which I personally wait a lot. Yeah, I'm along for them. So first of all, now we have pod priorities and priority classes. So in current versions, if you don't use it, you have a thing called quality of service for pods. And what it basically means. So when you define the pod, you have a request. You can set a request for pod and a limit for pod. So if you set both request and limit and they're exactly the same, then quality of service for this pod is guaranteed. So Kubernetes will do all his best to make it run always. Then if you have set request but did not set limit or they differ, then you have best effort. Okay, I'll try to schedule it, I'll try to run it, but I will evict your pod if something breaks. And then the last quality of service class, I don't set any request, I don't set any limits, then it will be like burstable. Probably it will work, probably not, I don't know. And now we have, and another feature that Kubernetes had is a critical pod annotation. So now they limit this usage of this annotation only to kubesystem namespace. So critical pods can be deployed only in kubesystem namespace. Again, for many workloads, it's not what you want to have. So now they introduce for us priority classes. So we have pod priority and everything related around it. And also we have priority-based preemption of pods. So based on a priority class, scheduler will decide which pods to evict. And another thing is we now have conditional taints to nodes. So it allows you to more flexible, allows you to do more flexible deployments. Okay. Are you tired yet? Okay, time for demo. So this is how Kubernetes dashboard looks in 1.8. As you can see, instead of showing us a dashboard, it shows me, okay, I am a Kubernetes dashboard and provide me authentication. So we have two options here. We can provide a kubeconfig file, which our administrator provides us, so we created it, or we can provide a token. And for kubeconfig, we just select a kubeconfig and do whatever we want to do. And for the token, I have to provide a token that again was initially created. Okay, I have some created here. So login. So this is our brand new dashboard. I can make it a little bit smaller if everyone is fine with that. And it's basically the same dashboard that you saw before. The improvement in the dashboard, so first of all, now you can see a nice graphics around allocated resources, for example. So we can see CPU allocation in our course and set limits, memory allocation, and then pods allocation. Now we can see that we have a bunch of roles. So this is like a basic cluster which almost doesn't have any deployments, and we already like more than 50 different roles in the cluster. And as you can see, most of those are system. So each system deployment system pod has its own role or even cluster role. So for example, we see there is a horizontal pod autoscale role, bootstrap signer cluster, cloud provider, so a bunch of those. And you can see here that those we have view role, edit role, so that they are defaults that you can use for provide view and edit capabilities for your users. And there is an admin, there is a cluster admin, is basically which we are currently using. Okay, and everything you saw before. Now the funny stuff, role-based access control. So I have created two users. I have created user called Alice and user called Bob. Both users have different roles, and so this is how it will look like. So let's take a look at the Alice. So this one is Alice. So first of all, we need to refresh. Okay, I have very simple token for Alice. Okay, first of all, as you can see, by default I'm logged in a default dashboard, and my user Alice has access only to the namespace called Alice. I created a separate namespace for Alice and said, okay, Alice, you can do whatever you want in this namespace. You can't do anything in other namespaces. There is no easy way to switch currently, because listing namespaces is a cluster role. So we have to manually do it or create a separate cluster role which allows only to listing list of namespaces. But again, some security experts consider even this is not secure, like knowing which namespaces you have. So namespace Alice. Okay, my Alice has access to deployments, but I didn't give her access to persistent volume claims or ingresses. That's why it shows me, okay, dismissal. But I want to show you. First of all, we have resources. So as you can see, currently I see, okay, I have one pod running in this namespace. And if we will go here, okay, this is my deployment. I deployed Nginx for Alice. And okay, I didn't give access to jobs. So this is a very flexible model which allows you to give specific set of permissions to a specific user. The previous version that Kubernetes provides, so RBAC, attribute-based access control, as far as I correctly remember, it wasn't flexible, so you had to do a lot of painful stuff for configuring different users and sharing the roles between them. Again, now we have a separate user called Bob. So Bob also has his own namespace. Okay, we asked for a token. He has pretty much similar deployments. Nope. Oh yeah, we are in a namespace default, so we have to go to our own namespace. So we have our deployment, and as you can see, if I'm a Bob and I want to see, okay, what Alice is doing. Yeah, it shows me exact one. It only shows me. Okay, I don't have any access. That is why it shows for me the previous screen that I was able to see. The only thing that I see the issue with this, so Kubernetes doesn't provide you. So they have like when you create your role binding, you actually mention like, okay, I have a user, but there is no simple way to say, okay, show me all my users, like where they come from, and then you are basically have the following options. You can use your token file that Kubernetes provides, and in token file you can, okay, this is my static token, this is my user, this optional set of groups. You can provide file, again, CSV file for basic authentication. And the only option that is more or less useful in production is integrating your Kubernetes cluster with OpenID Connect. So you have to provide OpenID Connect server, and user will authenticate through it, and then you'll define your role bindings for those, and so it will be much more more geared toward production. Okay.